Hi. So thought we'd do a little intro to the project today just for a good time. It's kind of fun. So there's a 465 data project along with this. Okay. You can do your work in the tabs labeled part 2 and part 3. So you're going to do some simulation of data. Okay. So here you see this. You're going to create new tabs for your stuff. I'm going to create a new tab right now and I'm going to do this. Again, if you weren't paying attention last time or you weren't in class, here's how we do this. Go into options and then add-ins and then go, and then you're going to click the check the top box and hit OK. And after it loads, under data, you should see data analysis now. Okay. Now, if I'm going to generate a discrete distribution, let's say these are the 3 numbers that could happen. I have a 3-sided coin or something. That would be kind of cool. And so there, the probabilities must add, of course, to 100%, and they do. So I'm going to data analysis, give it to me. Random number generation. Okie dokie. Okay, so I want one variable, that's one column of data. And I don't remember what I asked about in the worksheet. That'd be too hard to go look. So I'm just going to say, let's say I do 100 of them, or 1,000, or what have you. That's going to be 1,000 or 100 numbers down the page. Discrete distribution. So I go ahead and click here. And I highlight those guys. Whee! Now, it is imperative that data be listed such that this is the x and these are the probabilities. If you do it the other way around, Betsy will not be pleased. There they are. Cool. And so you just simulated some data. Now, let's say you wanted to simulate a plot. Oh, wait, I would just a minute. I don't know, some random discrete. I'll just write discrete here, whatever. Discrete, sure, why not? Now, let's say I want to do one that was binomial. I don't know, maybe, whatever. So I would click on here and I just go binomial, and then I would tell Betsy, hey, listen, I want the chance of winning to be 20%, or 30, I guess I did, because that's what I clicked on. And I'm going to play 40 times, okay? So that means here I'm going to play 40 times, and of course I should get 30% of 40, which is 12. That's what I should get. I'm watching. You're going to see 11, 12, 10, 8, 9. All around 12s are going to show up. And then generate that in column B2. That's where start it in B2, and it's going to go down. Oh, that's hot right there. Bam. And then maybe a guy wants to do a Poisson distribution. Poisson. The fish distribution, Jay. I know. I know. The Poisson distribution. And lambda, I'll just make lambda equal to 10 just for a good time because, you know, why not, I guess. Let's see. Bam. And there they are. There's some Poissons and so forth and so on and so forth. If I want to do a normal, cool. And I was just going to the data analysis. Okay. Look, I want to do a normal distribution. Oops, not Bernoulli. Dadgummit. I just want to do normal. By the way, Bernoulli is win or lose. Okay. But you're only playing one time. So it's binomial, but you only play one time. Like I'm going to flip this coin. What's the probability it's ahead? 50%. Oh, okay, cool. And you're just going to keep track. I played once and I won. Okay, tomorrow I'm going to play again. I played once and I won. Awesome. And then I lost or whatever. That's it. Then it's going to be used to 1 or 0 is all it's going to be in that thing, right? So it's kind of cool. This one here, let's say I want the average to be 300 pounds, standard deviation to be 25 pounds, whatever. Sweet. That's hot. And kaboom! There they are. Notice that these are not truncated. They're just showing all the way out to infinity there. So, you know, you can do this if that really bothers you, which it doesn't bother me at all. But if that bugs you, you're certainly welcome to trunk them. Just truncate it. And it wouldn't hurt my feelings if you did or did not. It makes no difference to me at all. I just don't really care. Cool. Oh, fart. I shouldn't have done that. All right, I'm going to do this. I'm going to copy. I'm going to paste special as values only. Cool. And then I can get rid of these guys. Okay, whatever. If that's something that makes you happy, you knock yourself out, man. I'm just here to help. And then once you understand how to do that, well, you're off to the races, okay? So you're going to be simulating some columns of data, okay? And then you're going to check the expected value of x plus y, the variance of x plus y, and so on and so on and so on to see how they match up with theoretical. Okay, well, listen, you know what the mean of this column is. The mean of this column is supposed to be 12. You know what the average of this column is. It's supposed to be 300, right? That's what it's supposed to be. So if this was what I was doing, was taking a look at these two columns, it's simply going to be and what happens when you add things? When you add them, you just add the means, yes? So if I did this, if I go equals the average of column E2 colon E101. Well, what do you know? 311, what's it supposed to be? It's supposed to be 312. Am I shocked by this? I'm not shocked by this. And you can do the same thing with x minus y and so forth and so on and so forth. You can do the same thing with the variance. Please use the calculator to find the variance. See how well they match up with them. Now you're going to go and you're going to throw a in front of x and b in front of y. So you're going to come in here and say this is my x column here. I'm just going to go I'm just going to do, let's say mine's 3x. That's cool, whatevs. So it's going to be equal 3 times this fella, and then paste it down. And I don't know, say mine was 2y or something, whatever. So then I don't know what mine is because I didn't really pay attention to the directions. I just write this stuff. I don't have to listen to myself. That fella, and then paste him down like thus. And then I don't know over here, then just do 3x plus 2y. And then simply go equal this fella plus this dude. Now, what should have happened to the mean? Come on, click, dummy. Oh, you can't click and it doesn't know what to do, stupid. There you go. So the average should be 3 times the first average plus 2 times the second average is what it should be. So it should be 636, I think, equals average. What? Look at that. It's awful close, right? And then do the variance of this column. And does that match up? And pay attention when you do variances of ax plus 2 or plus by. You know what should happen on those guys. So pay attention to that. Okay. Same ideas here. Okay. You're gonna match it up with theoretical and stuff. Piece of cake. Not very hard. Then also, okay. You're gonna look at this step 4 here. Well, it actually should be step 4 is right. I got rid of I used to have a different deal on there, but I got rid of one. All right, so then here's what we're gonna do. Okay. For instance, where am I at? Yes, back here. So I go back and I used to look at this column right here. So suppose I came across this column and it was mystery column. And I look at it and the first thing I notice is, geez, it's truncated, so I can't tell if it's normal or not. So what I'm going to do is I'm going to make a histogram, and I'm going to do that based on a pivot table. This is how you make a pivot table. Bring that down here and down here. The column needs to be labeled with something. It makes no difference what you label it with, but it needs to be labeled with something. See where it says sum? You got to make sure you change that to count. Nice. And then right click in this column over here. Right click and go to group. And as it starts at 216 and goes to 347, that's a difference of 131. Well, if I count by 10, that's going to give me like, 13, 14 bars. That seems like a lot of bars for a histogram. Maybe I count by 12, 15, maybe. Yeah, that's fewer bars. It's fewer bars. And I see what happens here. And what I'm going to do is I'm typically going to copy this and just make myself a new spreadsheet. Paste it in there and then go insert bar graph. Now, by the way, you will notice that there is if you look carefully up through all the stuff, you will find that there is a histogram button. The deal is it doesn't work on most people's computers. It's not been enabled. Now, this is one which is kind of cool. It's kind of weird. Remember, that was supposed to be normal. And yet, what does it look like to you? It doesn't look very normal to me. It doesn't look very normal at all. In fact, if I had to guess, I might go, gee, I don't know. It almost looks like it almost could be maybe binomial, but not quite. And you're like, well, I don't know, Jay. How would I know? It's a good question, sir, ma'am. Let's come back over here to my page, wherever my stuff was. Nice. So what I can do is go equals average of this column. I get the average is 300, basically. Yep, equals standard deviation. Sample. Okay. And, oh, you hippie, get up there. And go grab it. Now, I say to myself, well, interesting. Now, here's what it is, and you're like, oh, it's that. Now, if it were binomial, for instance, well, first of all, let's start off. If it were Poisson, remember the mean and the variance are the same. So I'm here to tell you right now, friends, this number here and this number here are not the same. That is not Poisson. Okay. Well, could it be binomial? I don't know. Remember that mu is equal to NP on binomial. That's cool. And the standard and the variance rather is equal to NPQ. Cool. All right, whatever. So when you think about this, you're like, oh, wait. To get from here to here, I'd have to multiply by something. And what is that something? That something would have to be Q. Does that make sense? To get from here to here, the difference is multiplying by Q. Wait, then what would Q be? Well, it would be this guy here, divide by this guy here. You get Q is about 9%. Well, if Q is 9%, obviously then P would have to equal 0.91 because P plus Q is 100%, right? So then you're like, wait, what? That's kind of weird. So then if you think about it, 200 or 300 is going to be equal to N times P. Well, then, wait, that's kind of weird. So then if I would take equals this 299 divided by 0.91, now we get N is like 328, okay? And I could look at that and go, well, yeah, okay, that's not bad. So then what I might do then is I could go in and see, I look at this and that doesn't shock me too much. It's possible that this is binomial. And in fact, as bad as my histogram looks on this one, I might lean binomial. If I didn't have a clue that this came from a normal distribution, if I didn't know that, I would say this is probably binomial. Okay, just because of looking at it, because it's not nice and symmetric like it should be if it were binomial. Okay, or if it were normal rather. So I will leave it open. You know, if you run into one, you're like, oh my God, I think it's this, Jay. You might be right. You might be wrong. I don't know. Back to my data, wherever my data went. Here it is. I'm going to grab the Poisson one just for a good time and just show you what that looks like. Actually, I'm going to grab that one and the binomial at the same time. Oops, darn it. Well, I was going to, hippie. Insert, pivot table rather, here we go. Okay, and I'm just going to go a little binomial first, okay, you with me? Now again, on the assignment, it will not say binomial, it'll just say variable 1 or what have you. So let's look at this thing. Oh, that's interesting. Let's go ahead and graph this. I think I'll just graph it the way it sits, darn it. I think that's what I'll do. Again, I just copy them and do them on another sheet somewhere. What in the Sam Hill is that about? Piece of garbage. Let's try that again, Jay. Good night, nurse. What just happened? Insert. Come on. That's what I wanted. Yes, that's what I want. Now give it to me. Uh-huh. Come on. Hurry up. Come on. And you're like, holy crap, what a mess. And I would agree. 100% I would agree with you on that. 100%. If I saw this thing in a dark alley, I would run, and I would run fast. Okay? That is just ugly data. There's no getting around it. What did we do wrong? Nothing. Nothing. It's just how it is, man. So let me come back over here to my stupid pivot table, wherever it went. I'm going to group these a little tighter just for fun and see what you think about it again. And going from, oh, what did you just do? Undo. Undo. Okay, wait, that's my problem. Don't have it highlighted. There you go. Group. And notice that it goes from 7 to 24. It's a distance of 17. Let's count by threes just for a good time. All right. And as soon as I look at that, I'm thinking to myself, wow, man, I don't know. Come on, give it to me. You actually can make the graph here. I don't like it as well, but you can actually make it here. And the fact that this is skewed says to me that I am not buying this as normal. If I look at this, and I'm looking at it, I'm like, it doesn't look normal to me. It looks kind of binomial-ish. Again, come back to your data wherever it disappeared to. Where's my data, dadgummit? Somewhere, there it is. So that was the binomial one. But if I was a mystery to me, I would say equals average of B2 colon B101. The hell is that? I didn't say S, did I? 12. And just for fun, I'm always going to do, well, just for fun, I'm always going to do the standard deviation. Same thing. And B2. And I'm going to get that. Now notice that if you square this, it does not equal that. So that tells me it's not Poisson. Okay. But remember, this is NP. That's the expected value of binomial. The variance is, oh, so equals, let's square it anyways here. This guy squared. So 7.8, this of course would be NPQ. And so then simply Q would be equal to this guy divided by this guy. So if Q is 66%, that means P is about 34%. So then equals 12 divided by 0.34. And you'd get N is about 35. And you're like, oh, yeah. And so that is a very good explanation for what it could be. That makes sense to me. I don't think it because looking at the histogram is skewed. I'm telling you, it does not look like any kind of normal distribution I've run into. Okay, so let's look at this guy here. Let's click on this again. Get rid of the binomials and put the Poisson one in there just for fun. Again, you should recognize a Poisson when you see one. Hopefully. I'm going to tighten this up a little bit. I'm going to go to group. And we're going from 2 to 19. That's basically a difference of 20. So let's count by 3, I guess, maybe or so. Yeah, that's nice. And you look at that, and you're like, okay, it does kind of, sort of look a little symmetric, but not much because of this bigger hump on this side. And I look at it and I'm like, first thing I'm like, well, maybe binomial. I don't think it's normal. We'll see. Go look at the data now, wherever the data went, and it is criminy right here. And I don't know what I'm doing. Equals average of C2 colon C101 equals, I'm just actually going to do variance dot S because that's just the square of it right off the bat anyways. How about that? C2 colon C101. Oh, look at that. Variance is equal to mean. That screams Poisson, friends. It screams it, baby. It screams it loud. Okay. So that's the sort of thing you're going to be analyzing the data with. It's going to be good times. Okay. Now, if you want extra credit, this is what I need you to do. Okay. Clearly, it's going to look something like this. Don't use mine. I'll get angry if you use mine. But, for instance, you could do blue eyes. Unfortunately, there's this cool plug-in for Google Sheets and stuff, but it's no longer works, which is kind of annoying. And it was so much easier to do it with, but whatever. And blue eyes might be 20% of the population. I don't know. I just made that up. 50%. I don't know. 0.25. I don't know. 0.05. Whatever it be, it better add up to 100%. Now, it's important you have to do this. I forgot to mention this to you. You need to put in here, because it's number generation. Are you with me? It's number generation. So you're going to go to data analysis, and you're going to do a discrete distribution. And the probabilities are here. Be careful, do not include the blue and the brown, and just include those. And they'll put the output range in A2. All right, sweet. Now, while it's already highlighted, I just go Control F. And we're just going to find and replace. We're going to replace the 0 with blue. Replace all. Oh, shut up. That's nice. 1, we're going to replace with brown. And 2, we're going to do with green. And 3, we're going to do with hazel. I don't really care. You can go to the Wikipedia page and figure out what percent of these there is. That's cool. I don't really care, but whatever. Okay, nice. There we have it. Nice. And so I feel good about that. So these are eyes. Now what I'm going to do is highlight this column. Okay, and then I'm going to go to the Home tab. No, I said the Home tab, darn it. And I'm going to go to Custom, I'm going to go Sort and Filter, Custom Sort. My data has headers, and I'm going to sort those like so. So here's my question to you. What percent of blue-eyed people have blonde hair, for instance? Okay, I don't know. But I'm going to do hair given blue eyes. Cool. So I have blonde hair, blonde, brown, red, and what am I missing? Oh, blonde, brown, black. Duh. Anywho, sorry, I'm kind of dumb today. Now, I feel like those are the only real colors you can have. If you have gray, you start out with one of these other colors. If you're bald, you had one of these other colors, so I don't really care. Like, if you're blonde, if you're blue eyes, you're more likely to have blonde hair, you know, more so than if you had, let me just go down the list here. Brown hair, boy, there's a lot of people with brown hair. I don't know, 65% or something. That's 85 total. I think about 12%. That makes us like 97, and then maybe 3%. Again, I like to just double check myself because I hate making mistakes. So there's 100%. Now this same thing, the same pattern, same idea will hold true for brown eyes, except obviously they're going to be a different proportion. Okay, and why is that? Because they are dependent. Okay, so for these guys, it might be something like I don't know, I'm making this up as I go. For people, don't get angry at me. No, that can't be right. Come on, dummy. Does that add up? No, I don't think so. Let's double check. Oh, I'm a little high. A little high. Let's knock that down to 5%. There we go. Boom, done. Sweet. So what I'm going to do is I'm going to simulate these people here. Are you with me? But I'm going to base it off of this data. And then I'm going to simulate these dudes. I'm going to simulate off of this data. And I'll do the same thing for the other eye colors as well. Yes? And they'll be different percentages. How do I know that? I had a girl in class a couple years ago who had black hair and blue eyes, and it creeped me out because they but they were not like kind of blue. They were like out of her eyes, out of her head blue. And one day I asked her, I had her in class 3 or 4 years, and I'm like, are those contacts? And she's like, why does everybody ask me that? And I'm like, because nobody with black hair has blue eyes, kiddo. You're one of a kind, and it's kind of cool. All right, so just be aware of that. This is how it's going to go down. We have, if you look right there, it says 17. Do you see it right there? 17 blue-eyed people. So I'm going to go to data. data analysis. I'm going to do 17 of them because there were 17. I'm going to click here, and I'm going to go in here and just grab these dudes. Boom. And I'd like them to start in column B2. Okay, boom. And then, while I'm at it, I'm just going to do them all. Okay, so now I'm going to go back to data analysis. Boom. And the thing that's going to change is what my probabilities are. So it's these fellas this time. Okay, and if I was smart, which no one's ever accused me of being smart, I would have done this ahead of time. And this isn't going to work. So let me back up just a minute. Let me back up. Maybe Jay isn't dumb. What you should do is click and drag and highlight these. How many browns you actually have? So we have 53 browns, it looks like. Is that with you? You with me on that? So keep that in mind when we do this. So I'm going to go into here and I'm going to, all right, random number generation. There was 53 of them this time. And then click on this crap and highlight these guys. And then this time I'd like my data to show up in B19, yes? Makes sense? Hit OK. Bam. All right, and I'm going to finish the whole rest of that column. Does that make sense? The whole rest of the column. This is hair. Okay, cool. And I'm sorry, sometimes I'm a little OCD. Not very often, but once in a while. Yeah, that makes me happier. Now, I'm going to highlight this column here. Be careful you highlight the column if you don't. If you just do find and replace, it'll do it on the entire page. And it will change this one into something else. It'll change this one. It'll change that one into brown. And it's not cool, dude. You're going to have 0 brown 5. And you're like, what just happened, dog? So if you want to change the numbers in this column, highlight the column, Control F, find and replace. So we're going to replace 0 with blonde. Make sure you spell it right. You look like an idiot when you didn't spell it right. Trust me, I know. And because it's gonna write it the wrong way that many times. So do it right. Oh, darn it. As I say, I don't want you using mine. Yeah, but here's what you're gonna have. Now, you're gonna get a whole set of data. Okay? And when it's all said and done, it's gonna be clear filled out with the greens and the hazels. I was lazy, I didn't finish that up. Okay. What you're gonna do is you're gonna create this table of data. Okay. You're going to give me this bit here too. Okay, I want to see that, but I want it off to the side. And so what I want to know is this: when I go in, what I can do is I can sort out. Here's the blue-eyed people, and I can go in, for instance, and do this. If I click on this right here, I can go insert. I can go to pie chart. Boom. Oh, fart. No, sorry, I can't do that yet. Never mind. Never mind. Jay, you're an idiot. Okay, watch this. What I will do is I'll go in here like so. Well, I can do this a couple ways. So I think the easiest way to do it is to go like something like that. I don't know, is it the easiest? It's one way to do it. I'll put it that way. It's one way to do it. And what you can do is you can make yourself a pie chart for these colored haired people. I forget what color we're dealing with. And you're like, oh, that's interesting. Cool. And then you can do the same thing wherever my data went. For God's sakes, where's my data? Somewhere. There it is. Aha. I can do the same thing with these guys down here, which are the brown haired people. And I could make another column somewhere, and I could do brown hair, whatever, and paste that data in here. Oops. Oh, did I not? I thought I copied it. I guess I did not. Control C. Anywho, Jay, that's pretty crazy, man. Yeah, highlight that data. Okay, and again, you can make another pie chart out of it. And the reason I want to make another pie chart of this goofy thing is because I'd kind of like to be able to compare and see if they look like the same percentages. This to me will tell me you did a good job, because when I look at your pie charts, they better be different percentages, because if they're not, that means that they're not dependent. Okay? Dependent, or I mean independent hair color and eye color, I would have the exact same pie chart for brown-haired people versus blonde-haired people versus whoever people. Okay? They'd be exactly the same percentages. And I'd be like, well, that's not helpful at all, man. So I will know that you've done it correctly if, when you're all said and done, your pie charts, for instance, you could use pie charts, look different from one another. You could also do this. Again, after you filled out the entire hair, I only copied the parts that were done, so don't worry about it. You could also do this. This kind of chart is very similar. It's called a side-by-side chart. You can get it in a couple of places. So there's a side-by-side, and then there's a stacked bar. I kind of like the stacked one. So what this looks like to me, it looks like, if you will, a brownie chart. All right. That is, instead of a pie chart, my pie charts are vertical and they're long. Notice how this one has a lot of blue. This one's got no blue. This one's got some red. This one's got a considerable more percentage-wise of red. This one's got a lot more green too. It looks like percentage-wise. Well, maybe not percentage-wise. Percentage-wise, green might be bigger here. Okay. So just be aware of that. That's what we're looking for. We're not looking for the total amount. We're looking for percentage-wise. Here it's like, almost half of the thing is blue. Clearly that's different than what we have over here on this guy. Are you with me? So that would be a way to judge yourself. And so what I'm looking for is, when you simulate some data, 10 columns of data where at least 6 of them have some sort of dependent relationship. Okay? And so that would be 3 pairs of columns. So in other words, it could be eye color, hair color. That's 1. And then you could do height and weight. That could be 2 more. Okay? And then it could be something else. Okay? And whatever it happens to be. And by height, I mean it could be short, medium, tall, whatever. Whatever, you could do it like that. It wouldn't have to be, you wouldn't. I probably easier if you didn't do it in inches. If you did it by like weighted people as high, whatever. It could be some, like I say, random dependencies, like what kind of hair color you have, and like fun you have, because clearly blondes have more fun, or like, the color of hair you have and ice cream preference. Oh my gosh, did you know there's a strong relationship between black-haired people who love white licorice ice cream? What? Oh yeah, it's true. It's true. That'd be cool. You are in charge, friend. If that's what you'd like to have, you knock yourself out. Okay? That's what I'm looking to have, and yeah, have some fun with it.